Hey guys, I'll discuss this problem, chef and aunts, which is from CodeChef January Long Challenge 2021. So this is the problem statement. You can read it from here. I'll provide the link in description. So I'll discuss what the problem asks us. So there are n lines. There is an ant colony where ants live, and there are n lines on which ants are traveling, and they are traveling towards the intersection of these lines, which is the point O. Okay, so all these ants are traveling towards point O. Now the problem says that whenever two ants meet, whether at point O or not, if they meet, they reverse their direction and start moving in opposite direction. So whenever two ants meet, it is considered a collision. It is considered a collision. So this problem asks us to calculate the total number of collisions that will happen among these ants. Okay, so let's pick a simple scenario. Let's say we have one single line, and we have this ant, which is moving. This ant moves towards left, right, and this move towards left, and they collide somewhere here. And after collision, what happens is they reverse their direction. So in the next scenario, we can see the ants reversing their direction. So this ant now moves here, and this ant now moves here. Okay, now if we think in this way, like letting the ants collide and letting them reverse their direction and then count further collisions, the problem becomes complex. Like, you cannot think in this manner. Like, how can you simulate the process with the bounded time we have? But if we change our point of view, if I observe that these two ants are actually identical ants, there is no difference in these ants. So if I say this is ant 1 and this is ant 2, and this has to be ant 2, no, this has to be ant 1 because it reverses direction, and this has to be ant 2. But actually the ants are similar, so it does not matter what these ants are. This can be ant 2 and this can be ant 1. So which means that I can simply let the ants pass through each other. So this ant passes through the ant 1, and there is one collision. So because the ants are identical, so it does not matter whether this is ant 1 or ant 2. So yeah, this seems fine. And now it becomes very convenient to think. Let's say we have this as the midpoint O. There are 3 ants here and there is 1 ant here. Now how many collisions will be there? This ant will simply pass through all these 3 ants. So there will be only 3 collisions. If I put one more ant here, this ant will also simply pass through these ants. So there are 3 more collisions. So which is in total 6 collisions. So which means that every ant at one side of the line will collide with every aunt on the other side of the line. So if there are, let's say, AL number of aunts on left side and there are AR number of aunts on the right side, then the total number of collisions on this line will be AL into AR. So I can also denote aunts on the left side as negative and aunts on the right side as positive, the aunts on the positive side of the axis. Okay, this seems easy. If I have only one line, this is the answer. But there are n lines which are intersecting in this manner. Okay, also I'll show you one case where just simply passing, like not reversing the direction of aunt, will cause a problem. And this is the case when collision occurs at point O. So I'll show you why. Let's suppose this aunt collides with this aunt at point O. If I let them simply pass through each other, so there was only one collision occurred and there is no more collision happening. So this is only one collision and no more collisions happen if I simply let them pass through. So this aunt right over here, this moves here and this aunt moves here. So this gets removed and this gets removed. Okay, so now there are no more collisions, but the question says that the aunts reverse the direction. So if the aunts actually reverse their direction, so what will happen is these two aunts right after collision, they start moving here. So this aunt was moving down and this aunt starts moving up and this aunt starts moving left. So there is no more collision here. So they collide at O. So there was one collision and then there is another collision happening here. So that's 1 plus 1. So this gives us two collisions. Now the thing is, so the hypothesis is, if the aunts collide at point O, the intersecting point, they have to reverse their direction because there might be some aunts behind them, like on this side, there might be some aunts behind them to which the current aunt can collide. So that's why this aunt has to reverse the direction. Okay, so now let's consider the sample case from the problem. This will give you more clarity. So I'll draw it. So there are two lines. One ant is at -2, one ant is at 1, another ant is at 2. So this ant is at -2, this ant is at 1 and this ant is at 2. Now I'll start by considering the aunt with the smallest distance from point O. So I'll consider this aunt right over here, this aunt. Now this aunt will not collide with any other aunt at point O. Reason is there is no other aunt which is at the same distance as this aunt from point O. Like there is no other aunt which is at distance 1. So it will not collide with any other aunt on point O and it will simply pass through all the aunts which are in front of it, like on the other side, which are in front of it. So that's one case. So now this aunt 1 has passed doing one collision. We have these two aunts left. So this distance from O, this is 2, and this distance from point O for this aunt is also 2. Now since the distance is same, they will meet at the same time at point O. So if they meet at point O, they will now reverse the directions. So one collision occurred, another collision occurs at point O, and when they reverse the direction, the final scenario is like this. This was aunt 1, which is going to the left side, and this is aunt 2, which collides at point O, and it's also going to the left side because it has collided at point O, so it will reverse its direction. And this aunt also starts going in opposite direction. So in total there were 2 collisions. So now the algorithm that we have got is this. So this is the algorithm which says that pick the smallest distance, pick the aunt with the smallest distance from point O, like in increasing order. So we have to sort the aunts according to their distance from point O. And if it is the only aunt, which means there is only one aunt with this distance, then it will simply pass through other aunts. Like in this case, there was only one aunt here. There was only one aunt here which had distance of 1 from point O, so it simply passes through the other aunts which are in front of it. So there was only one aunt in front of it, so there was only one collision. In the third case, if it is not the only aunt that has this distance, like there are 2 aunts with the same distance, like distance 2 and distance 2. So these 2 aunts collide at point O and reverse its direction. So whenever an aunt reverses its direction, I'll add it, whenever an aunt reverses its direction, it will collide with all the other aunts behind it and it goes out of scope. Out of scope means this aunt will not contribute to any more collisions. It will simply pass through the other aunts which are behind it. Okay, so yeah, so that's the algorithm we got. So finally, what we have to calculate is collisions at point O. Collisions at point O plus, I should rather type it, plus collisions not occurring at point O. Okay, so we have to keep in mind these two things. So collisions occurring at point O and collisions not occurring at point O, and this is my answer, the sum of these two. So with this algorithm in mind, I'll show you my code. Okay, so here it is. So at first I take the input, the number of lines. N is the number of lines. Then I create a map. D stands for distance. So this key stores the distance from point O, and this will store the aunt number. Like I'm numbering each aunt. Like for example, I am numbering this map int vector int D. Wait a minute. Okay. Yeah. So I'm giving a number to each aunt. Like this is aunt 1, this is aunt 1, this is aunt 2, this is aunt 3. So I'm giving a number to each of the aunts, and I'm storing them in a vector. Like for each distance, suppose there are 10 aunts with a distance of 5 from O, so I'll save their numbers, like which aunts are they, which is having a distance of 5 from O. So I'll initialize aunt number as 1, and this is a vector. Actually they are actually providing the number of aunts at runtime. So I'm temporarily saving information in this vector, and then after I know the size, like this M, then I'm creating a vector for after I know the total number of aunts. Then I'm creating this vector to store for each aunt the line number on which it is currently is, and the side of the line. Side means whether it is on the positive side or whether it is on the negative side. So from each line from 1 to n, number of aunts positive on the positive side are 0 now, currently, initially, and on the negative side are also 0. So there are m aunts on line I get m, and then for each aunt I'll input the distance of this aunt from point O, and so this distance can be negative, which will represent the direction in which it is moving. So that does not matter for us. I'll take the absolute value of that distance, and I'll push back this aunt number in this map. Okay, so initially I'm considering the aunt is on negative side, and if its distance is positive, then it is now assigned the positive side, which is 1. So negative side is represented by -1 and positive side is represented by 1. So in this vector I'm pushing the aunt number and the information regarding this aunt, which is on which line it is and on which side it is. So then I increment the aunt number, and if it is on the positive side, so positives plus plus, otherwise negatives plus plus. At the end, for each line I'm storing this data, where how many aunts are there on the positive side of this line and how many aunts are there on the negative side of this line. So that's a pair of integers. This is the array, which is a pair of integers. Okay, now for each aunt I'm saving the line number and the side. Like v was the temporary vector, and now I'm directly using this array so that for each aunt number I can access the information regarding that aunt in O of 1 time. So yeah, so for each aunt in this vector I'm getting the aunt number, I'm getting the line number, and getting the side. So I'm saving it in this array. So for aunt number 1, their line number and the side of the line on which it is saved. So now let's initialize answer with 0. Now we will count all the collision occurring at point O plus all the collisions occurring at other points. So okay, so this map D already had all the aunts. Okay, all the aunts with different distances are in this map. Okay, so I gather the distance, which is element dot first, which was the key. So now then I see if there is only one aunt at this distance from point O. So like if there is only one aunt, like in this case, this is a bit messed up. Yeah, so I'll do this. So okay, at a distance of 1 there was only one aunt, but at a distance of 2 there are 2 aunts. So there is only one aunt at a distance of 1. So this will simply pass through. So then there will be no collision at O because it is the only aunt with this distance. So I gather the aunt number, like this is the only aunt, so I gather d dot distance dot front, d of distance dot front. Then I gather the line number directly from this aunt's array, line number and this side, whether it is on positive or negative side. So if the aunt is on the positive side, and so it will simply pass through the aunts on the negative side. So the aunts on the negative side are this line of line number dot second, because line array stores positives and negatives. So positives are the aunts on positive side, negatives are the aunts on negative side. So this adds up, this aunt collides with every aunt on the other side. Okay, so if it is on the negative side, it will collide with every aunt on the positive side, and after doing so I'll remove this aunt. So this was on the positive side, so I remove one aunt from positives, and I remove, this was on the negative side, I remove one aunt from the negatives. Okay, so now I continue, like I move over to the next distance. Now if this is not the case, if there are more than one aunts, I'll reach here. So when I reach here, I'm calculating the collisions occurring at point O. So I gather the aunt number for each aunt having this distance, like each aunt having a distance of 2. I'm gathering the line number, and then I'm gathering on which side they are, if they are on the positive side. Now if they are on the positive side, like here, so they will collide at point O and then reverse the direction, okay, after colliding. So what will happen is, like if it is here, collides here, and then it reverses its direction. So now it will collide with all the aunts which are behind it, so on the same side of it. If this was on negative side, it will collide with all the aunts on the negative side as well. So that's it. The current aunts collide with all the aunts on its own side except itself. Therefore I have done -1, and then I remove this aunt. Similarly, if it was on negative side, it will collide with all the aunts on the negative side except itself, because it is reversing its direction. So yeah, then I remove the aunt. And then since all these aunts are colliding at point O, I'll add 1 to the answer because there is one collision occurring. So yeah, that's it. That's the answer. I'll provide a link to my solution. You can see it. Okay, if you have any feedback, you can give it in the comments below, and also if you found it helpful, you can like the video. I'll be posting more such content. So if you want to tune in, you can subscribe. Alright guys, bye.